This week we have timing operations. We're going to review the timing modules that the STM32F board has. It starts with a bunch of timers. You have advanced control timers from timer 1 and timer 8. They are both 16 bits. You have general purpose timers. Timer from timer 2 to timer 14th, where 2 and 5 are 32 bits, 3, 4, 16, and then 9 to 14 also 16 bits. And then you have basic timers, timer 6 and 7, both at 16 bits. And the reason why they separate these ones is because they are connected directly to the DAC, and they are used to produce signals when you use your DAC or DAC. What's going on inside of these timers? Like super simple basic timer block diagram. You're going to configure the peripheral clock for the timer that you want. That clock comes out, passes over a prescaler, and then affects the counting or the counter that you're going to use. That counter can generate events or interrupts depending on what you want to do with it. And this is the clock tree. We notice here that timers are going to run on the APB bus, and the APB bus needs to be parameterized accordingly here, or the timer clocks need to be parameterized accordingly to the AHB prescalers, APB prescalers, everything divisions, and then we have here a multiplication based on your system clock that we know that it's running at 168 megahertz. What else do we have? We have two types of watchdogs. Watchdogs are good to detect and resolve malfunctions due to software failure, and they trigger system resets or interrupts. And we have this independent watchdog, best suited for applications that require to run independently of your code, but in terms of timing constraints, it has lower timing constraints. Or you have this window watchdog that it's best suited for applications that needed to react with a certain accurate timing window. We have also something called system timer or C-stick. Normally it's a timer that is going to be used by your real-time operating system, but you can also use this C-stick for other timing purposes, such as normal timer to debounce a pin or produce a delay, for example. And at last we have this integrated real-time clock module. It's an independent BCD timer or counter, and it provides time of the day, clock calendar, 2 programmable alarm interrupts, and some programmable wake-up flag with interrupt capability, and includes also an automatic wake-up when you're working on these low-power mode. That's pretty much it in terms of timers. And for the example of the week, we're going to parameterize the timers. We're going to play around with timer 2 and other timers if you want, but around these general purpose timers. So let's see how they work and spend some time with timers.